Namaskar. So, in the linear programming models, the main task was to fix the level of different decision variables so as to maximize profit or minimize cost. The purpose was to allocate resources in an efficient manner in which the time factor was not considered. However, in many business problems, the management is frequently confronted with making a sequence of interrelated decisions where the objective is to optimize the overall output of the entire sequence of decision over time. The mathematical technique for making such sequence of decisions over time is called dynamic programming. The word programming has been used in mathematical sense of selecting an optimal allocation of resources, and it is dynamic as it is particularly useful for problems where decisions are taken over several distinct stages over time, such as every day or every week or maybe a month also. Today, dynamic programming has been developed as a mathematical technique to solve a wide range of decision problems, and it forms an important part of every researcher's toolkit. On dynamic programming, a large problem is split into sub-problems, each of which involves only a few variables. Dynamic programming method is applicable in solving a wide variety of problems including allocation, inventory control and replacements. So, in previous lecture we discussed the particular definition of dynamic programming approach. Also we discussed the characteristics of dynamic problems. The problem can be divided into stages with policy decision required at each stage. Each stage has number of stages associated with it. The stages are various possible condition in which the system might find itself at that stage of the problem. The number of states may be finite or infinite. The effect of the policy decision at each stage is to transform the current state into a state associated with the next stage. Given the current stage, an optimal policy for the remaining stages is independent of the policy adopted in previous stage. For dynamic programming, in general, knowledge of current state of the system convey all of the information about its previous behavior necessary for determining the optimal policy. Hence, it is Markovian property. The solution procedure begins by finding the optimal policy of each state of the last stage. A recursive relationship is available which identifies the optimal policy for each stage with n stages remaining. Given optimal policy of each state with n-1 stage remaining, using the recursive relationship, that is function equation, the solution procedure moves backward stage by stage, each time finding the optimal policy for each stage of that stage until it finds the optimal policy when starting at initial stage. In last lecture we discussed one example, employment smoothing problem. Today we'll see capital budgeting problem. So let us see one example. You can see on your screen, that is one example, one question. A manufacturer company has 3 sections: producing automobile parts, bicycle parts and sewing machine parts. Okay, he has 3 sections of producing automobile parts, bicycle parts and sewing machine parts. The management has allocated rupees 20,000 for expanding the production facility. What is allocation? Total 20,000 rupees are allocated for expansion. In the auto parts and bicycle part section, the production can be increased either by adding new machines or by replacing some old inefficient machines by automatic machines. The sewing machine part section was started only few years back. Thus, the additional amount can be invested only by adding new machines to the section. So, not necessary of replacement. The cost of adding and replacement the machines along with the association expected returns in different sections. What are three sections given? Automobile part, bicycle part and sewing machine part. Okay. So, it is given in next table. So, this is one table. It is given in data in question itself. One is no expansion. If there is no expansion, there is no cost and no return. The second is add new machine. In case of auto part section, if you add a machine, it requires 4,000 rupees investment and return will be 8,000 rupees. In bicycle parts, new machine investment is 8,000 rupees and return is 12,000. In sewing machine, investment is 2,000 rupees and return is 8,000 rupees. For replacement, there is no replacement for sewing machine. But in auto parts and bicycle parts, you can replace if it is required. It requires 6,000 and return is 10,000. Bicycle parts replacement required 12,000 and return is 18,000. So this is given data. Okay, this is given question, capital budgeting problem. Okay, what is required? It is required to find the, what is required? Expansion plan which may be yield the maximum return. Select a set of expansion plan, means automobile parts to be returned or replaced or addition of new. Bicycle parts, how many parts addition is required, and sewing machine, how many parts or new machines are required to purchase. So this plan is required which may yield the maximum return. Okay. Here, each section of company is a stage. So, you can divide this problem into stages. So, here each section of company is a stage. At each stage, there are number of alternative for expansion. Capital represents the state variables. So, here capital 4,000 rupees, 6,000 is variable. Let us consider first stage, auto parts. Auto part section. Auto part section. You can see the second and third column. Auto part section. There are three alternatives for auto parts. No expansion. Then new machines to be purchased or added and replace old machines. The amount that may be allocated to stage 1 may vary from 0 to 20,000. Maximum, considering three sections or three stages, the expenditure, maximum expenditure is 20. But now you can consider 0 to 20,000 expenditure for single auto part section. We'll decide how much to spend afterward. Finding of optimum solution. It will be the overspending if it is more than 6,000. You can see in the table for 6,000 cost, the return is 10,000. So the return of various alternatives is given in a, now we'll take this in a table. Okay. Now you draw this table. Auto part sections, stage 1. Here the investment is varies from 0 from 20,000. So if 0 investment is there, so there is no return. Then 2,000. So in the first column shows the amount of investment in 1,000 rupees. So second, if 2,000 rupees investment is there, there is also no return. If 4,000 rupees investment is there, then return is 8,000. If 6,000 is there, so you can, if you even you are spending 6,000, if you purchase a new machine, add new machine, you will get 8,000, or if you replace it, you will get 10,000. Okay, in this way you write. So the maximum amount returned in this auto part is, for adding a new machine is 8,000 rupees, and for replacing an old machine is 10,000 rupees. So optimal return initially is 8,000, and after 6, more than 6,000, the optimal return is 10,000 rupees. Okay, so here, so maximum 6,000 rupees you can spend. Even you spend 8,000, 10,000, 12,000, the optimal return in this stage 1 will be 10,000 only. So when the capital allocated is 0 or 2,000, the only first alternative, no expansion, is possible. So the return is of course 0 in first case. When the amount allocated is 4,000, the alternative 1 and 2 are possible with return 0 and return 8,000 rupees. We selected alternative 2, and when the amount allocated is 6,000, all the 3 alternatives are possible. So giving return 0, 8,000 and 10,000 respectively. So we select the 3 with return of 10,000 and so on. Okay, this is stage 1. Now move to stage 2. So stage 2 is, it will be for second, that is bicycle part. Let us now move to stage 2. Here again the 3 alternatives are available for auto part section. No, it is for bicycle part section. For bicycle part section. Here the first case is considered, along with that next case is added in it. Next case is added. So you can, your table will be like this. Your table will be like this. If there is a 8,000 rupees, if there is a 4,000 investment, so there is nothing but auto part section is there. If there is 6,000, then you will get a 10,000 rupees from previous table. If there is a 8,000 rupees investment, from previous table it is 10,000, but from new table you will get 12,000 rupees in. For 8,000 you will get a return of 12,000 rupees. If 12,000 investment is there, so here 10 plus 8, 20,000 rupees you will get. So in this way, here the x2, the state x2 represent the total amount allocated to the current stage, that is stage 2. The preceding stage, stage 1. This means you have considered here stage 1 and you are adding the amount in stage 2. So previous amount plus new amount. Similarly, the return also is sum of current stage and preceding stage. Thus the x2 is less than 8,000, only the first alternative, no expansion is possible. So here, but x2 equal to 8,000 and return of 12,000 is possible by selecting the second alternative. If x2 is 12,000, then 3 alternatives are possible with maximum return 20,000 from alternative 2. The optimal policy consists of a set of 2 decisions, namely adopted alternative 2 at the second stage, and again alternative 2 at first stage. So here from this table, so you will get this. Now move to table 3, stage 3. So stage 3 consists of sewing machine. So initially you have considered auto parts plus bicycle parts plus sewing machine parts. So now move to third table. Third table is sewing machine. Here you can see, you can get 2 alternatives there. So as there is no replacement old machine, so you will get the no expansion or add new machines. So for x3, 20,000, x3 is the value in stage 3, x3, 20,000. The optimal decision for stage 3 is alternative 2, which gives a total return of 36,000, which gives total return of 36,000 rupees. Okay, so this involves a cost of 2,000 and leaves 18,000 to be allocated for stage 2, and one is combined. So from this table, from this previous table, for allocation of 18,000 rupees, alternative 3 is to be chosen, which costs 12,000 rupees. For remaining sum of 6,000 from 7.6, so decision alternative 3 is to be selected. So thus the optimal policy of expanding production facilities 332. Okay, so decision is 3, 3 and 2. So which can be elaborated as replace old machine with automatics in auto part section, replace old machine with automatics in bicycle part section, and add new machine to the sewing part section. This policy gives the optimal solution of rupees 36. That is the return, maximum return. So in this way you can decide, means you have decided the your plan, expansion plan, that automobile part to be replaced, then bicycle parts to be replaced, and sewing machine parts to be purchased. So here 6,000 plus 12,000 plus 2,000, total 20,000 you will spend, and return will be 10,000 plus 18,000 plus 8,000, that is 36,000 you can earn, and this is what the optimal solution we found out. Okay, so this is about the solution. So in first automobile part, the third case, bicycle part the third condition, and for sewing machine the second condition. By choosing this expansion plan, you can get a optimum return, that is 36,000. Okay, this is about this problem. If you have any doubt, you can ask in a doubt clarification session or write in a comment box. We will discuss your doubts in next lecture. Thank you.